Hi and hello to everyone. We are the participants of NIYANTRA 2013 contest from Sona College of Technology, Salem. Our project entitled LabVIEW based farm automation using Android aims at modernizing and upgrading the level of farming with finer results to the farmers everywhere. It relieves the farmers provided the appropriate usage of the Android phone is known to the farmer and also the appropriate usage of internet is known to the farmer. Our project mainly focuses on the following aspects. The first one is power management, as shown here. Next, the robotic controlled arm for farming using image processing. The third, monitoring and controlling the field according to the parameters that are constantly being monitored and processed. Next is the Android application controlled automation, which uses dashboard version 1 for monitoring and visualizing. Instead of Android phone, if an iPad is used, it will support the higher version of dashboard, which provides a major advantage in terms of monitoring and also controlling the aspects of the field with interfacing with the LabVIEW. Fully automated control system through the internet is possible from anywhere in the world using laptop and computers. Here we have the main front panel of the server system. Now the client can access the main panel of the server system using the Internet Explorer and by typing this URL. We are thankful to NI for providing us the chip kit. All the inputs from the field such as temperature, humidity, soil condition are fed to the chip kit and interfaced with the LabVIEW. First we look at the robotic arm. Here we are using 3 motors to control the whole arm. The first one is to move the arm along x-axis. The second motor moves the arm along y-axis. The second motor is used to control the arm in the y-axis. The third motor is used to cut the required item like ripened fruits. This part shown here is the automated solar tracker, which is a part of our power management system. Here we are using 2 LDRs to align the solar panel in the required direction perpendicular to the sun ray. Now as the sun ray falls on this LDR, the panel automatically aligns in that particular direction. After some time, when the sun ray falls on this LDR, the panel automatically aligns its position according to the ray. Now let's take a look at the sensor network, which analyzes various parameters such as the soil moisture, security breach, temperature and humidity. The photodetector here will sense the light and automatically turn on the solar panel tracker. This is the panel for turning on the solar panel. This sensor here is for security purpose. If anyone intrudes in the farm field, automatically there will be an alarm, as you can see there. Now automatically the alarm will be activated, and even in the dashboard it will be activated. There are 2 types of soil present here. Based on the condition of this soil, the values are being plotted here in this graph. Now when the sensor is kept in the other soil, automatically the appropriate values related to that soil will be shown here. Now comparing both the soil conditions, the appropriate action would be taken. We can also view using this dashboard application. The moisture content varies depending on the soil condition. The plots of the two soil types are shown here. Now the same plots and the same values can be observed in this dashboard run by the Android application. As we can see here, this is the server system and this is the client system. The person handling the client system can take control over the server system in any part of the world through the internet, just by clicking request control of VI. By this way, we can control the farmland from any part of the world. We can enable the robotic arm. We can switch on or off the automatic solar panel tracker. We can monitor the tank level. We can start or switch off irrigation, and we can control the spraying of fertilizer. All this is done by a web publishing tool, which is a feature of LabVIEW 2012. We can observe the field conditions and also the parameters which are getting changed in this dashboard or in the mobile. As we can see, we can monitor the tank level. We can see the humidity percentage. We can monitor the rainfall. We can activate irrigation, and as soon as it is activated, it will be notified in this dashboard application. We can also activate fertilizer, and it will also be intimated in this dashboard application. Alternative energy sources will also be displayed accordingly. Next is the image processing part. The image is acquired and then it is detected as to whether it is ripened or not. If the fruit is ripened, it is cut. There is also analysis for the purity of grain and also insect detection. This part shown here is one of the main part of the image processing section. This is used to find the purity of the grain. For demonstration purpose, we have two types of grains, this and this. Now the acquired image is the image of rice, and the purity is given here. Which is about 85%. Another sample for purity check is shown here. The acquired image is shown and the purity of this grain is about 70%. As explained before, this robotic arm is used for cutting the ripened fruits. Now, when the fruit is ripened, automatically it will be cut by this arm. This process is shown in the front panel of this LabVIEW. The image is acquired, and when it is detected as a ripened fruit, automatically the red LED will glow since it is a tomato. Now we will demonstrate what happens if another fruit is detected. As shown here, this is an orange. Since it's an orange, the image acquired here is processed, and in the fruit detection palette, the orange LED will glow. Now we will present an overview of the front panel of our project. This tab is for power management. As you can see, the power from the solar panel is displayed here. The battery energy rating is also displayed here. And there is also a tab for grid energy. Next, coming to sensor network, the graph for various parameters like soil, temperature, humidity are plotted in this graph. Now let us look on the block diagram of our project. This is the block diagram for the image processing. Here the image is acquired and it is processed. The chip kit part is shown here. The various inputs are fed to the chip kit and the processing is done in this part. This is the whole block diagram of our project.